video, I'm going to see how many proofs I can get done before lunch ends and help you out with these, starting with number 7, part A, which is our first proof. In the first proof here, they have the statements for us, and we are filling in the reasons. They have given us that E is the midpoint of AC and BD. Keep in mind that the midpoint gives you congruent segments. This will mean that E is the middle of AC, making AE congruent to EC, as well as E is the middle of BD, making DE congruent to EB. Our goal is to prove triangle ABC. So I'm going to go ahead and do some highlighting. We want to get triangle ABC congruent to triangle CDA. Currently, we do not have enough information to get those two triangles congruent to each other. So we're going to be using a pair of triangles that we're able to get from our givens. Our givens are kind of leading us to the pair of triangles that create what I like to call the bow tie picture. So we're going to start with these two triangles. They have vertical angles here and here. And so these can be proved congruent. Let me see. A, B, E. Those are not the ones they went for. Whoops. We can get them with side angle side, the two I was just highlighting, but they went for these instead. Just have some options. Sometimes when we have the statements, it makes them harder for me to follow because they made different choices than I would have. So we're going to have those vertical angles, but they're going to be where the 3 and the 4 are labeled, which makes them easier to find. These two triangles can be proved congruent to each other through side angle side. So let's get to line 4 with what we just found out. We had our given. We used the definition of midpoint to get the congruent segments from that given. For line number 3, we were proving angles 3 and 4 congruent because vertical angles are congruent. You can also say vertical angles postulate or vertical angles theorem. You cannot say definition of vertical angles, and you cannot just put vertical angles. So be very careful about how you write that reason. A moment ago I said we were looking at the picture and we're able to tell that these are congruent through side angle side. Once you have the pair that you're able to prove congruent to each other, you want to think about what those have in common with the triangle pair you would like to have. We would like to have triangle ABC. So let's see, ABC is this large bottom sort of half, or like right side half of the picture. We would like this one and the top portion. And so we want to think about what those have in common with the triangles we were just able to prove. Well, they share the angle at 1 and 2. That is both part of the pink triangle as well as the new yellow and the new green triangle. So we're going to use that with CP, And another thing they share is that line AB can match with CD. So for this proof, we are using CP, for more than one piece of the triangle. So that's pretty interesting. You can use it for as many pieces as they have in common. Remember that once you prove a triangle pair congruent, you can use CP, to prove any of their corresponding parts are congruent. It takes 3 parts to prove the triangle is congruent, and then that allows you to have 3 additional pieces after you have proved them congruent to each other. The green triangle and the yellow triangle are touching triangles, and they share a side. The side they share is AC. And so they have AC congruent to CA, which is the same as AC congruent to AC. This is the reflexive property of congruence. And now that we have that, let's kind of look at what we're using. We are using angle 2 and side CD and the shared side. And so these 3 things that we're using to prove our new pair of triangles are the side angle and then the side that surround that angle. So side angle side is going to be our reason. I do want you to know that we did not start with an easy proof. This proof is one that I consider to be one of the harder ones to do. as I described them on spice level, this is, one of the spiciest ones that we might end up working out. Now, they tried to help us out by giving us the statements, but as you know, we're needing to get to the level of blank proofs. Here is another proof, and we have lots of triangles in this one, and they have the statements. We're using a given triangle to get to another pair of triangles. That's a bit weird. We're also using perpendicular lines, and the perpendicular lines are causing you to have 3 steps in the proof. Notice that the perpendicular lines are all right here. These 3 steps are related to the fact that you have perpendicular lines. So let's look into this. We've got our given. They gave us a pair of congruent triangles. They told us FHL is congruent to JHK. My goal is to get triangle LGH congruent to triangle KIH. Things that the new triangles have in common with the original triangles are the side LH and KH, also angle 3 and angle 4. So those 2 items can come from CPCTC and can now be used in the pink triangles, which are our goal. So the thing that we have not done yet is use those perpendicular lines, and so we're going to do that right now. Perpendicular lines lead to right angles. So we're able to get right angles here, and I think we need to put the 5 on the other side of the line, so kind of like scribble that out, move it over so that it's inside of the triangle here. The perpendicular lines were part of the given. They lead to right angles all the time. You can either write definition of perpendicular, which is what I put, or you can put that perpendicular lines make right angles. Now, the next part of the proof depends on the reason we are going for. If we are wanting to use hypotenuse leg, then the next statement would have to be that these triangles are right triangles. Definition of right triangles. Since I can tell now by looking at the picture that I'm going to be using angle, angle, side, I do not need to state that they are right triangles. I instead need to state that angle 2 and angle 5 are congruent to each other. They are, 2 and 5 are congruent because all right angles are congruent. Now that I have the 2 angles and the one side that is not between them, I can say that my reason is AAS for the triangle pair that I was trying to prove congruent. Let's see if I can do one more before lunch ends. Here I have a picture. It has 2 triangles on the left, 2 triangles on the right, and the large top and the large bottom triangle. So there's 3 pairs of triangles, and I need to focus on, like, what do I want to use? There's more than one way to do this proof. I'm going to work this the easiest way possible. The given of RT and RV and NT and NV lead me to the 2 triangles on the left side. Putting the given into the proof here. Marking the given. I notice that these triangles are touching. They share a side, so I can add that into the proof. Rn congruent to Rn. Reflexive. Property of congruence. Make sure you say reflexive. This makes these 2 triangles congruent by side, side, side. Now, I know that these 2 triangles do not have what my goal is. My goal is to get TS and VS. But what I did was I proved the triangles I was able to prove. Now I'm going to think about how can I use the triangles I just proved to incorporate them in a way that will get me another pair of triangles that has the pieces I want. So I want to have TS and VS. There is a way with using the triangle pair on the right side to get there, but it's not the easiest route. So I'm going to be using the full big triangle on the bottom and the big triangle on the top. And if you think about what they have in common with the yellow triangles, they have side RT and RV, but we already knew those two sides. Another thing they have in common is angle 1 and angle 2. So I can get angle 1 and angle 2 through CPCTC. This is an angle in the new triangles that we want. And we can also notice that these two aqua triangles are sharing side RS. So I can use that and say RS is congruent to RS by reflexive property of congruence, just like RN was used in the previous triangle. Now we're using RS. And just to kind of sketch this out to see the path here, if this is triangle RVS, we now have angle 2, we have RV from the given, and we have now side RS. And we can see that side angle side is going to be my method for the triangles. And I have the 3 pieces in the proof right now, so I'm ready to name my new pair of triangles. If I say RTS, I would then say RVS, lining up all my corresponding parts. My reason would be side angle side. And now that I have these two triangles congruent, I can say that TS and VS are congruent because those are a corresponding part of these new triangles. Remember that this reason that I'm using here, CPCTC, stands for corresponding parts of congruent triangles are congruent. Will always be used right after you prove triangles congruent to each other, and it will always be telling you one of their corresponding pieces that you did not have originally.